4.6 is all about our graphs of our other trig functions. So we've already handled sine and cosine, it's time for the other four. We're going to start with tangent. Just like we did when we were making our other graphs, we are going to look at our table. So I'm actually going to start with 0, and when I do this, I'm thinking about my unit circle. So right here would be 0, my point there is 1, 0. Tangent, if you recall, is when you do y divided by x. So 0 divided by 1 is just 0. So I can have a dot right here at 0. Next I'm going to go to my pi over 4. So that would be this dot right here. The reason I skipped the pi over 6 is because it's just not a pretty number to graph. I already know that from my experience with tangent. I'm going to try to stick to ones that are going to be a little bit nicer to get on my graph. For pi over 4, you have radical 2 over 2 and radical 2 over 2. When you divide y divided by x, something divided by itself, that's just 1. So let's get our scale in here real quick. And then you can plot that at positive 1. So I'm just counting by 1 for these because it gives you your nice shape of your tangent graph. Next would be pi over 2. So that's at the top of my unit circle, which would be at 0, 1. Again, tangent is y over x. Since I know I can't divide by 0, that's going to be undefined, which when you graph that is going to be an asymptote. So I'm going to have an asymptote right here at pi over 2. Now, since I've run into an asymptote, so I can't really tell what's happening with my graph, I'm actually going to continue my table backwards a little bit just so I can see another point. So I'm going to go to negative pi over 4, which will still be radical 2 over 2, but now it's negative radical 2 over 2 for the y. So when I divide these, there's still something divided by itself, but this time one of them is negative, so my answer is a negative 1 instead of a positive 1. And I didn't put space for it on our table, but if I went back to negative pi over 2, that would be down here at 0, negative 1, which would give me, again, something divided by 0. So that's going to be another asymptote. So when I graph this, it almost looks like your cubic. So kind of like a squiggly, that wasn't great, but coming up, turning towards my 0, and then coming back up. That's my basic tangent graph, and it's going to be repeated over and over and over and over. The thing is, technically tangent is starting at 0, and then it's being repeated again. If I follow the same pattern down here, 0, up, asymptote. So that's technically between these two spots is my first period. I find that that's very difficult to think of when I'm graphing. So I just remember that tangent starts at 0, and I know it's that general kind of like a cubic graph, and I can graph that and get my asymptotes. Once I have my asymptotes, it's pretty easy to place everything else. Go ahead if you want with your table, filling in what these values are, or I've kind of already shown you the pattern down here. But you can see where I'm getting my undefined. And if you remember rather, period is your distance for a full cycle. Technically, a full cycle goes from 0 to pi, but that doesn't look like a full cycle, so I do find it's a lot easier to count between the asymptotes. So my asymptotes go from negative pi over 2 to positive pi over 2, or from pi over 2 to 3 pi over 2. So my period is pi, because that's the distance between the two. So for tangent, my period is pi. Sine and cosine, it was 2 pi, so tangent's a little bit weird. You don't have an amplitude for tangent because it doesn't have a maximum. It keeps going up and down forever. But if you did have, let's say, y equals 2 tangent of theta, if it was a sine or a cosine, that 2 would be your amplitude. For tangent, it just moves this dot. Instead of being at 1, it's up at 2. And instead of being at negative 1, it's down at negative 2. If it helps you to think of it as the amplitude, that's fine. Just know that it's not technically an amplitude because it's not technically your minimum and your maximum. Do make sure you get a complete graph all the way across all of these. Hopefully, again, a little bit nicer since you're on paper. Next we have our cosecant graph, which if you recall is the same as 1 over sine of theta. So I'm just going to start my graph. Sorry about that. So I'm going to start my table at 0. If I'm thinking about my unit circle, at 0, I'm at 1, 0. If you recall, sine goes with your y, so this is like 1 over y. So I have 1 over 0, which is undefined. So cosecant actually starts as an asymptote. At pi over 2, so at 0, 1, when I do 1 over my y, that's 1 over 1, so my point is at 1. And I am going to keep that same scale that we had earlier. At pi, so I'm over here, at negative 1, 0, 1 over my y would be 1 over 0 or undefined. So at pi, I'm again at an asymptote. At 3 pi over 2, I'm down in the bottom of my unit circle. At 0, negative 1, so when I do 1 over my y, it's 1 over negative 1, which is negative 1. And then at 2 pi, I'm back where I was for the 0, so that's back with another asymptote. Now between these, to see what it's looking like, it's essentially going to be like a parabola almost, or like a U, bouncing up like that. Or in this case, down because it's a negative 1. One thing that I think helps see this is if you actually look at your sine graph. So I'm going to go ahead and plot my sine graph so you can see what that looks like. So here's my sine graph. Since I know that cosecant is the reciprocal of that, I know that's 1 over it. When I'm doing my graph, it kind of helps me to think of, well, anywhere that sine was at 0, I've now become 1 over 0. So all of those turn into asymptotes. So when you think about it, it starts as an asymptote, it ends as an asymptote, in the middle it's an asymptote. Normally sine goes up and then back down. Well, this time when I'm at my up, I'm going to do the opposite of everything else. So like about where it was at a half, if I'm the opposite of a half, now I'm up here at 2. So instead of thinking of it at that top as just kind of staying between those, it's going away from each other at those tops and bottoms. For some people, it helps to think of what the points are. For others, it helps to think of your sine graph and just go away from it. I think that since we're going to be doing lots of different things with this, if you can remember that cosecant always starts as an asymptote and then therefore ends as an asymptote, it's an asymptote in the middle, then you know you're going basically like little parabolas or U's away from those. So all of these that were zeros are now asymptotes. Up here I was at the top, so now I'm going up away from my graph or up away from my center. Here I'm going down away from my center. Your period for cosecant took a full 2 pi for you to get that top part and that bottom part, so it is 2 pi. Also know that since cosecant goes with sine, they're going to have the same period. As far as amplitude, again, you don't technically have one because it's not a maximum. But if you were graphing like y equals 3 cosecant of theta, these dots right here would be up at the 3 and down at the negative 3. So it is affecting that point. It's just not maximum, minimum. It's just where you're putting those vertex, basically, if you will. Next, we're going into our secant graph. You can do it the same way we did cosecant by making your table and filling in your points. Or you can do it the second way I showed you on cosecant by getting your cosine graph in here, since I know that secant is 1 over cosine. I want you to try to do this. I will get both filled in up here. Do remember that that's going to be like doing 1 over your x value if you're looking at your unit circle. If you choose to start with your cosine graph, you are looking at something kind of similar to what we did with the cosecant. So anywhere that there is a 0, it's now become an asymptote because that's actually 1 over 0. So I have asymptotes at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. From there, the top points are just like our cosecant, become like those parabolas going up. The bottom points become like the ones going down. So it looks very much like your cosecant graph. If you made your table, you would have noticed that you were starting at 1, then you were undefined, then you were at negative 1, then you were undefined, then you were at 1. How I remember these. I know sine looked like the S, so it started like the zeros, which means that cosecant should start and end with those asymptotes. Cosine starts at the top. It's like that sideways C. So secant should also start at the top. So since cosine started and ended at the top, secant starts and ends at the top. The difference there being, of course, that you're going up and away from the middle, which means in between those is my middle spot. And then I have asymptotes there. Sine starts at 0, cosecant starts at asymptotes. Cosine starts at 1, so secant starts at 1. It does not start with an asymptote. Technically, my first period goes from that like half of a U to this half of a U. I always try to think of where it starts, so starting at 1, and I know I'm at an asymptote, and so I put all my asymptotes down. Your period for secant is also 2 pi, just like it was for sine, cosine, and cosecant. And just like for those, you don't technically have an amplitude, but if you had graphed for secant theta, now those dots would be up here at 4, down here at negative 4. Right. Cotangent is our last one. You could use your tangent graph to help you remember this. So I know, based on my previous notes, that tangent started at 0, went up, down, but having the asymptote over here. But it started at 0, which means cotangent is going to start at the asymptote, which is kind of nice. So cotangent, just like cosecant, if that helps you remember, start as asymptotes. Cosine doesn't because it doesn't have any asymptotes. And then because my period for tangent was pi, so is my period for cotangent. So I can space those asymptotes out by pi. Oops. Going back a second just to like our cosecant, secant graphs, notice that these asymptotes are also spaced out by pi distance, even though the period was 2 pi, because it took 2 sets of your asymptotes to get those tops and bottoms. Whereas for cotangent, tangent, you can have a full graph here between your asymptotes. So again, tangent started at the 0, went up to the right. So at that first dot, it was at 1. I'm still at 1. Sometimes I find that's a little confusing to think of it that way, but I'm going to walk you through this and I'll do you the table as well. The next dot was an asymptote, so now it's at 0. My next dot would have been down here so that I can have that same pattern repeated. So I'm still down at that negative 1. So tangent went up kind of like that. Cotangent is going to come down. Like that. If you're making your table, you're starting at 0. Looking at your unit circle, that's at 1, 0. Cotangent rather is x over y. So 1 over 0 is undefined. Pi over 4, again I'm dealing with the x and y both being that radical 2 over 2, so when I divide them, I'm getting 1. At pi over 2, I'm at 0, 1 now, so when I do x over y, I get 0. So forth and so on. Make sure you have your complete graph in there. As you are doing all of these new ones, it will take a little bit of practice. Try to remember where I have said the asymptotes are, because if you can get your asymptotes, it'll make it a lot easier to fill everything else in.